Hey guys, so today I'm going to be going over the USACO 2025 Open Contest for Bronze Problem 2, which is more cow photos. So, to solve this problem, we need to first understand it. So essentially, Farmer John is trying to take a picture of his cows, and there needs to be 3 criteria to be met. The first one is that the cow's heights need to increase and then decrease, and they increase to a certain point and then decrease. So for example, 1, 2, 1, it increases to 2 and then it starts to decrease. The second criteria we need to meet is that the cows next to each other, they can't have the same height. So we can't have cows like this, because there's 3 cows next to each other which have the same height, 1, 1, 1. So the adjacent cows can't have the same height. And then the last requirement we need to fulfill is that the cows, like the line order, needs to be symmetric. So essentially, it reads the same forwards and backwards. So 1, 2, 1 is also 1, 2, 1 when read backwards. It's like a line of symmetry basically. It's the same thing on the left side and on the right side. Alright, so we get, and based off these 3 conditions, we need to find the maximum amount of cows we can include in our lineup so that these 3 conditions are met. So let's go through the first sample input together. So the first sample inputs, there's like 2 test cases. Let's go through the first test case. So 4, 1, 1, 2, 3. So looking at this sample inputs, the maximum amount of cows that will satisfy all 3 conditions is 1, 2, 1. It's like 1, 2, 1 or 1, 3, 1. And basically, these 2 sequences fulfills all the 3 requirements. They increase to the middle points, which is 2 and 3, and then decrease. They're also symmetric, which means that they read the same in backwards, 1, 2, 1, read backwards is 1, 2, 1. Same with 1, 3, 1. And no 2 cows next to each other have the same height. So our answer, when we output the answer, we get 3. Let's look at another test case. The second test case is 3, 3, 2, 1. And from here, it's a little different. We can't have 3, 1, 3. Although it is symmetric, it doesn't increase and then decrease. It decreases and then increasing. We want something that increases and then decreases at a certain point. So that doesn't work. So out of all the possible sequences, the only ones possible is 1, 2, and 3. There may be some symmetric ones, but they don't fulfill all the conditions. So sequences are 1, 2, and 3. These, like, you can have individual sequences, and these are the only sequences that fulfill all conditions. 1 by itself is symmetric, and it increases, or it doesn't really increase or decrease, but 1 fulfills all the requirements. So, yeah. So based off these sample inputs, we need to recognize a couple of observations. It appears that the frequency of cow heights appears to affect the number of maximum cows we have. For example, we want something like this. So if we have more than 2 of a number, we can repeat that, and so it becomes like a symmetric pattern. So if we have 3 2 times, if we have 4 2 times, that's even better. If we have 5 2 times, that's even better. So the bigger numbers we have that are more than equal to 2, we can include that in our symmetric and keep on adding that to here. So we want to try to form a pattern like this. So 5, 4, 3, 2, 1, 2, 3, 4, 5. So we want to have numbers that are greater than or equal to 2, that have a frequency or appear more than 2 times. Then we can use them in the forward part, which is increasing, and then the backward part, which is decreasing. So this is like the pattern we're trying to look for. So with this in mind, let's look at some custom inputs that I made. So a key tip when doing these USACO problems is you want to make your own inputs. They only give you a couple of inputs, and they may not satisfy some. There may be some edge cases you're missing, or some special cases. So let's look at some of the custom test cases I made. So 6, 1, 1, 2, 4, 1, 2. So if we want to mimic the pattern, which is like that increasing and then decreasing, I can write it here, like 1, 3, 2, 1, 2, 3, something like this. We want to keep track of the number of occurrences. So the more numbers that have an occurrence greater than or equal to 2, we can include it in our array. So let's look at, for this array, let's count the number of occurrences of each one. So I'm going to do it over here. So 1 occurs 3 times, 2 occurs 2 times, and 4 occurs 1 time. So based off this, in our pattern, we can create a sequence that looks like this: 1, 2, 4, 2, 1. So this one would be the maximum amount of cows we can include that satisfies all conditions. This is symmetric. 1, 2, 4, 2, 1 reads the same forwards and backwards. It's increasing to 4 and then decreasing. And then also there's no 2 adjacent cows next to each other. Notice how even though one has 3 numbers or 3 occurrences, we don't care. We only use 2. Also, even if one has like 4 occurrences, like 1, 1, 1, like it has 4 occurrences, we don't care because we can't use 1 like 2 times in the increasing part and decreasing part because it needs to increase and then decrease. Also, you can't have adjacent ones. So we really only care about numbers that have 2 or more. So 1, 2, 4, 2, 1 would be the biggest one. We're using the most amount of cows here, and this satisfies all conditions. So this length would be equal to 2, 4, 2, 1. That would be 5. Also, notice how it's always going to be an odd number because you can't have. If you're going to increase and decrease at a point, you can't. You're going to have like one number in the middle. If that makes sense. Alright, so before I get into the code, let's go over one last example. So let me just erase this part. Alright, so last case is 10 for 10 cows. 1, 2, 1, 2, 3, 5, 5, 4, 5, 4. And basically, we want to use the same like method counting the number of occurrences. So we count 1s, 2s, 3s, 4s, and 5s. So 1 occurs 2 times, 2 occurs 2 times, 3 occurs once, 4 occurs 2 times, and 5 occurs 2 times. Alright, so basically we're going to count the number of numbers that have occurrences greater than or equal to 1. So we can do 1 and 1, 2 and 2. We can't do 3. If we could do 3, that would be a possible sequence, but that's not the max because we can include 4. And notice how even though 5 has 2 occurrences, we don't include 2 5s because that would not satisfy, that would fail the adjacent heights. They can't be the same. So we only include 1 5. So this would be the maximum number, and we get 1, 2, 4, 5, 4, 2, 1. That satisfies all the conditions. Increasing and decreasing, that's check. No adjacent, that's check or same next to each other. And then also symmetric, that's also a check. So that's the answer. So your answer would be a length of 1, 2, 3, 4, 5, 6, 7. It would be a length of 7. So you might have already grasped our method or algorithm, but basically we're going to be counting all the frequencies of the numbers, and we're going to be counting up to the last number because we don't want to include the last number. Our last number is going to be in the middle. We're going to be counting that and then counting the number of 2's and adding 1 for the last number. So let me show you my code. So notice how I'm inputting the test cases first, and then using a while loop to loop through the test cases, inputting n, and then creating a vector for my cow heights. And then here we're using a frequency map, or map. Basically a map's really good because it's automatically ordered. We don't need to sort like our data structure afterwards, because in this case map is already going to be sorted. Here, when I'm inputting it, I'm going to save a little time, and I'm going to increase the occurrences of each cow height when I'm inputting it, so I don't have to make an additional for loop afterwards. This is going to save a little bit of time. Here, I'm going to count the number of 2's. This is going to be my variable for counting the number of 2's. Then I'm going to loop through or map, and if this is going to be skipping the last number because we're going to save our last number as the middle one, because we don't want the middle one to occur twice. We want to save it for the last one in the middle. So that's the maximum possible, to include the maximum possible occurrences that have greater than or equal to 2 occurrences. So here, that's breaking at the last. And then here, we're just counting. So the it basically is an iterator. It's like each iteration, it's like the key and the value. Basically, we're checking if that value is greater than or equal to 2, which is the occurrences, and we're going to increment or count each time this is true to count the number of 2's, and then multiply this by 2 because you know how it's symmetric. So you can this occurs on increasing side and decreasing side, and we're going to add 1 for the middle part. For the map, it basically looks like this. So wait, let me go back. So basically what I drew here, this is basically the map. So this starts at 2, this starts at 2, this starts at 1, this has to go into 1, 2, and this is 3. Basically, this is like the map structure. This is the key, and this is the value. This is the key, and this is the value. This is the key, this is the value. This is the key, this is the value. This is the key, and this is the value. So basically, a map has a key and a value. The iterator pointing to the second, that's the value part. And then the first part is the key. So the key is a number, and then the value is the number of times it occurs. Yeah. So this is my solution. And I just forgot to explain the time complexity. The time complexity of our solution is pretty good. It's pretty optimal, only using 1 for loop. And in USACO, we're try to have a time complexity of O of n. And then if we can make it O log n, then that would be even better. But basically, this is going to be pretty optimal. We don't need a double for loop, triple for loop. So it's going to be pretty optimal O of n times. Let me know if you guys want me to explain the other problems in this contest or other problems in general. I can also do some code forces, tutorials too, but let me know if you guys want more videos. I also have a written editorial I'm going to be posting in the description for you guys to read if you guys need more explanations. Thank you for watching.